A binary operation, that's the triangle operation, is defined on a set of real numbers R by x operating on y is equal to x plus y plus 10. Find A, identity element, B, inverse of 3 and negative 5 under the triangle operation. So we'll try going through the solution for this question. This is a binary operation question. You have been given the definition for the operation. Now the question wants you to find the identity element. Now before you find the identity element, the operation is supposed to be commutative. That condition always hold. For you to find the identity element or the inverse or whatever, the operation is supposed to be commutative. Now in this case, the operation is commutative. That is, x operating on y is supposed to be equal to y operating on x. That is why even they are asking us to find the identity element. Okay, so for the A, we have x operating on y to be equal to x plus y plus 10. The question wants us to find the identity element. So we have to use a variable or an element of our choice to represent the identity element. We need to define our identity element. Therefore, let's say E represents the identity element. All right. Now we are using this E to represent our identity element. All right. So in that case, the basic definition from the identity element: a variable or an element operating on its identity element gives you the same element. Therefore, x operating on its identity element, that is the E, supposed to be equal to x. Now this is the basic definition for identity element: an element operating on its identity element or operating on the identity element should be equal to the same element. All right. Now what we have to do next is we have to expand this operation using the definition given. The x is representing whatever variable or element that is before the operation, and this E here is representing whatever operation that is, or whatever element that is after the operation, although the E is the identity element. Okay, so from the definition, whatever that we are having before the operation operating on whatever that we are having after the operation is equal to what you are having before the operation plus what you are having after the operation times 10. In this case, we are going to have x plus E plus 10, and this is supposed to be equal to x. What are we finding? We want to find our E, that is our identity element. So we try making E the subject. If that is the case, then we are going to have our E being equal to what? X. This x cross the equal to sign, we have negative x and then minus 10. In that case, our E will be equal to negative 10. Therefore, the identity element E is equal to negative 10. So that is the A. For the B, the question wants us to find the inverse of 3 and negative 5. But first, let's find the inverse equation or the expression representing the inverse. Once again, let's define our inverse. The inverse, we can use any variable of our choice to represent the inverse. So once again, let's say Z represent the inverse Alright, so we are using Z or Z to represent the inverse of, let's say, an element X. If that is the case, then per the basic definition, an element operating on its inverse gives us the identity element. I take it again. An element operating on its inverse gives us the identity element. Therefore, we are going to have, let's say, an element X operating on its inverse, that is Z, supposed to give us the identity element, and that is E. So we want to solve or want to make Z the subject because that is our inverse. So we try expanding this definition or this operation here. We try simplifying this using the definition for the operation. So this is going to give us X plus the Z plus 10 being equal to our E. And our E, we had negative 10 for that. So we want to make Z the subject. Therefore, we are going to have the Z to be equal to, we have negative 10 already there, minus X minus 10. So this is going to give us minus X minus 20. So this is the expression for the inverse. Therefore, if the question wants us to find the inverse of 3, then this will be equal to, we have negative where the X is, because that is our element. So we are putting 3 there. So negative 3 minus 20. And this will give us negative 23. Therefore, the inverse of 3 is negative 23. We do the same thing for the inverse of what? Negative 5. So inverse of negative 5, this will be equal to, we take the expression, and the expression was negative X minus 20. So we are going to have minus or negative, we have the X, and our X is our element. Now our element is minus 5. So minus 5 minus 20, and this is going to give us 5, positive 5 minus 20, and this is going to give us minus 15. Therefore, the inverse of negative 5 is negative 15. So that is the question 1 of the elective mathematics theory paper of the Wassce 2020. Thanks for your time.